I'm Jim LeDuc. I'm happy to welcome you to the Galveston National Laboratory and tell you a little bit about the unique partnership that we have in place between the Sandia National Lab and our facility here in Galveston, Texas. We have a very unique resource where we can work on all pathogens up to and including the most dangerous pathogens such as Ebola and Marburg and various other viral hemorrhagic fevers. We have all levels of biocontainment, and we work to develop vaccines and drugs and diagnostics for use for these most dangerous pathogens. That skill, then partnered with the unique resources that exist at Sandia, allow us to merge our capabilities to really bring state-of-the-art technology to address some of these most difficult challenges. Sandia brings to us very unique skills in engineering, in nanotechnology, and micofluidics that allow us to really use these modern facilities to jointly address critical problems such as the current Ebola outbreak that's just winding down now in West Africa.
I think most of the strengths for the Sandia and UTMB collaboration lie in the fact that we actually have a Sandia facility here on the UTMB campus. What this allows us to do is to get instant feedback for a lot of our products. There's been instances where on a Friday afternoon I've had a PI come in and they've wanted a chip done for preliminary evidence for a grant. And I've been able to actually draw something up, burn it on the laser printer, and give it to them at the beginning of the next week. So they are able to get their evidence and get a grant submitted. If we were at a remote location, I don't think we'd be able to get that sort of turnaround time. One of the primary projects we're working on is the SpinDX platform, ranging from its construction, development, and deployment. Here, the discs are fabricated from a layer of double-sided adhesive film sandwiched between two cast acrylic layers. The top layer contains fluid access and vent holes, while the microfluidic channels are cut into the adhesive layer. The discs are manually assembled and then pressed together. To be able to bring in a PI and show them the technology in action is definitely helpful. Trying to explain some of this technology to someone who's got a biological background can be somewhat challenging. Just so to actually show them the chip or the technology in action, let them hold it in their hand, see it working through all its steps is very helpful.
SpinDX is a microfluidic platform for detection of analyte using bead-based immunoassays. The approach is based on binding of analyte of interest to functionalized capture particles, followed by sedimentation of particles through a density media in a microfluidic disc. Capture silica beads are incubated with analyte of interest. Next, analyte-specific fluorescently labeled antibodies are added and the reaction is allowed to proceed. For a multiplexed assay, non-relevant fluorescently labeled antibodies are added and the mixture is loaded on the disc on top of the density gradient. When the disc is spun, the bead-bound analyte with fluorescently labeled antibody pass through the density media, leaving behind the unbound analyte and antibodies. Centrifugal microfluidics relies on centrifugal force to actuate the flow. It is proven to be a versatile method because of its simplicity and ability to integrate any assay steps into a single device. The approach is fast, sensitive, requires minimal sample preparation, and can detect multiple targets simultaneously. The enhanced sensitivity is due to isolation of the beads from background and concentrating the fluorescent signal that comes from secondary antibody on beads at the tip of the channel. After centrifugation, the signal from the beads is quantitated by fluorescent microscopy. The technique is highly adaptable for rapid development of new assays by preparing beads with antibodies against new analytes. This experimental setup is currently being tested in a clinical laboratory at one of the UTMB hospitals.
morning, Charlotte. How's the experiment going?
Good morning. It's going very well.
Great. What step are you at?
I'm loading a slide right now.
Great. You want me to hit start?
Yes, sure.
All right, great. If you'd like to save this run,
Yes,
I'll
do.
make some notes.
That would be great. Dr.
I
Berry.
appreciate it.
So we look forward to working together with our partners at Sandia in the future, and we thank you very much for this opportunity.